Okay, we're going to solve a moles to moles problem now. So there's a couple of points that I want you to keep in mind as we solve one of these problems. First, recognize that you must have a balanced chemical equation. Now, if you're in regular level chemistry, they're probably going to give you the equation balanced already, so you don't have to do anything. But if you're in honors or AP level chemistry, then you have to double check and make sure that the equation that was given was actually balanced. All right, now once you can confirm that that's true, then you can go on to the next step. Now the next step just involves looking at the coefficients of the substances that are involved. Don't worry if there are more than two substances in the problem. There probably will be, okay, but you really only need to focus on the two that the problem calls for. Those coefficients are the molar ratios, and those are very important because the molar ratios tell you how the proportions work. Kind of like when you're making a cake and you need to know how many cups of flour to how many cups of sugar. That kind of proportion is what I'm talking about. Those are the molar ratios. Now, when you know the molar ratios, you can create a conversion factor, and that conversion factor is built from the molar ratios of the substances in the problem. And you're going to use that to figure out how to convert from moles of A to moles of B. All right, here's the video, and I'll see you afterwards. Okay, we're going to solve a moles to moles problem now. And you can see here at the top we've got a chemical reaction. Of course, it's a good idea to make sure that it's balanced, and you can check that out. A lot of times teachers are going to give you the equation already balanced. So it depends on the level of chemistry that you're in. Typically, if you're in a regular or general level chemistry class, you're going to get everything balanced. But if you're in an honors or AP level class, you really should double check and make sure that you're dealing with a balanced chemical equation. So let's take a look at this situation here. So what's going on is two sodiums are reacting with water, and whenever you take an element like sodium or anybody else that happens to be in group 1 and you put it in water, you produce a base, in this case sodium hydroxide, and you also produce some hydrogen gas. Now the question says, what is the total number of moles of hydrogen produced when 4 moles of sodium react completely? So it's a good idea to circle numbers in the problem whenever you see them. And it's also a good idea to circle what it is that you're looking for. In this case, we're looking for moles of hydrogen when we've got 4 moles of sodium. All right, so in this particular case, we always start a problem with the given information. So I'm going to write 4 moles of Na. All right, so MOL is typically an abbreviation for the mole, and Na is the symbol for sodium. Now, how are we going to figure this conversion out? How are we going to figure out the number of moles of hydrogen? Well, the problem involves sodium and hydrogen. So we really need to just focus on those two substances. We don't need to worry about the water. We don't need to worry about the sodium hydroxide. We're just going to focus on what was asked in the question, which was sodium and hydrogen. Now the ratio, the molar ratio between these two is the same as the coefficients. In other words, 2 moles of sodium is to every 1 mole of hydrogen, and that's H2. It's molecular hydrogen. It's bonded together, so we count it as 1. All right? Whenever you don't see a coefficient in front of a formula, you can assume that it's just 1. Okay? So now we're going to use that information. We're going to create a mole ratio. So here's how it works. You're going to put the 2 moles of Na in the bottom, and you're going to put 1 mole of H2 in the top. And the reason why you want to do that is because you're setting up this problem so that moles of Na are in the top and canceling with moles Na here in the bottom. So these guys cancel with this. Top cancels with bottom. Now you're saving the numbers, okay? You're going to save the numbers, but I just wanted you to see that the units are what cancel. You're going to need the numbers in order to figure out what the answer is. So in the end, you're going to basically take 4 times 1 and divide it by 2. Okay, that's how you're going to solve this. So 4 times 1, that's easy, that's just 4, and then divide by 2. So in the end, what you get is 2 moles of hydrogen gas. Okay, that's a little m there. So, of course, 4 divided by 2 is 2, and then we end up with 2 moles of hydrogen gas. Okay, so that's it. There's nothing more to do in order to figure out the moles of hydrogen. These kinds of problems, moles to moles, are really pretty easy. They just require one conversion factor. And again, just to recap, for any kind of problem that's a moles to moles problem, you only need to focus on the substances that are involved in the problem. So we only needed to focus on the sodium and the hydrogen. And it's from the balanced chemical equation that gives us this molar ratio of 1 to 2. Okay? We put the 1 mole of hydrogen in the top, we put the 2 moles of sodium in the bottom, okay? Not the other way around. All right, that's all I have for you. If you need more practice, just watch another video, and I'll see you next time. Okay, you just got done watching the moles to moles video. So let's recap the most important points. First, you must start with a balanced chemical equation. Can't get around that. If you're in regular level chemistry, they're probably going to give it to you, but if you're in honors or AP, watch out, okay, because they do like to trick you with that stuff. Second is, once you have the balanced equation, you look at the coefficients. The coefficients give you the molar ratios between the different substances, and then from that, you're going to create a conversion factor. I recommend that you take the time to download the worksheet and solve this problem on your own and follow all the steps. Even if you know how the problem is supposed to be solved, just the act of taking the steps and following the steps and practicing the steps is really what is going to train your brain for following the correct procedure in these kinds of problems. All right, that's all I have. Watch another video, and I'll see you next time.